Project 2.7, the digital watch. This here is the complete and finalized digital watch project, and here is the prototype for it. The prototype here uses a CR2025 3.3 volt lithium ion coin cell battery to power the circuit. And then this is an ATtiny85 being used as the main processor. This here is a DS1307 RTC chip, and it's being used to read the time and keep the time and date. And then this is an OLED screen. It's 0.86 inches on either side, and it's 128 by 32 pixels. It's the SSD 1306. So the ATtiny here is communicating using I2C, and it's reading from the RTC. Through code, it sets the RTC's initial time and date, and then the RTC, using this crystal here, can just count up as long as it has power, which is what the coin cell is doing. The RTC is connected along these lines, with serial data being on the positive and serial clock on the negative for I2C communication. It's also how the OLED is being programmed, and this is all done through the Tiny. So the Tiny is reading the RTC and then transmitting to the OLED. The RTC is programmed using this here ISP header. There is a slight conflict because the RTC is so small, it needs to use some functions on the same pin. So here MOSI and serial data are the same pin, and then also serial clock for I2C and the serial communication here are on the same pin. What this means is that if they're used normally, I2C either doesn't work or the programming doesn't work. But this is mitigated by the switches here. So there's two switch states. Right now it's kind of in an operating mode. If these are switched off, I2C will stop working. But if the switches are both switched to the other position, then it can be programmed. Additionally, it should be noted that the time is in 24-hour format rather than 12-hour AM PM style. And then this is the finalized watch design here. It features a couple different components. So this is a single pole triple throw slide switch, and this is a button. And the idea was that with this finalized design, you could have three modes. So a power off, a set time, and a set date. And then when you press the button, depending if it was on set time or set date, it could increase the day and then or the minutes, and then if you hold it, it would decrease the day or the minutes. Unfortunately, when the PCB came, the DS1307 here, which is in surface mount version, was in the wrong package, so it couldn't be soldered up, and that means that the PCB doesn't work. Regardless, there's also an acrylic lens here. This sits on a slight indent built into the Fusion case design. Unfortunately, because the case was slightly damaged in transportation, you can see it's slightly warping here. The lens no longer sits evenly across, and the idea was that it was going to be connected to the case with epoxy resin. This would additionally waterproof the case, but because there are gaps, there was a risk that epoxy would get on the PCB, and so that's why it's separate. And as well, the case here is attached with two screws here and here. And what that means is that the bottom of the case is actually detachable. It's a two-part case. And when you remove this case, you can see the battery and the ISP header similar to here that's poking out on the bottom. And that means you can program it and switch out the battery and interact with the elements without having to take apart the entire thing. You can just take off the bottom, easily interact, and then put it back on. And then finally, there is the band, the watch band interactive elements. There is essentially a slight indent in the Fusion model that allows this watch band to just click in, and you can see there it happened. And this means this is a 20 millimeter watch band, so it could theoretically work with any watch band. This was just one from Amazon. And that's it pretty much for the digital watch. Thank you for watching, and I hope you have a great day.